Hello and welcome to another GCSE revision video, and in this video we're going to be looking at rotations. In mathematics, if we move an object around a point, it's called a rotation. That can be any point, whether it's the object's own centre, or whether it's the origin, or whether it's any other point on the graph. If we're moving it around a point, we call it a rotation. And that's about all there is to it. Okay, well, so much for the theory. Let's have a go at putting this into practice. We're told to rotate this shape 90 degrees around the origin. Okay, so our origin is this point here, which is 0, 0. And 90 degrees is perpendicular. So we didn't actually specify which direction, but if no direction is given, the expectation is that a positive increase in angle is a counterclockwise direction. So that's the direction we measure. Generally speaking, a negative 90 degrees would be this direction. Okay, so how do we rotate a shape 90 degrees? Well, there's quite a few ways, but the most important method is to draw a line from the point that you're rotating around. In this case, it's the origin, but it could have been any point. So you draw a line from the point you're rotating around to one of the vertices. And then you're going to want to draw another line that's exactly the same length but at the required angle, and you might want to use either a set square or a protractor to get that angle, and you could use a ruler to measure the length of the line. Now I would say that puts us here. That's the same length but 90 degrees. So this is where my 1 point is going to be. Now the next point is at 4, 1. So if I draw this line here, I want to draw another line that's the same length but at 90 degrees. So that'll put it around here. Again, you would use a ruler and a protractor. I'm actually using a little mental trick which I'll tell you about afterwards. So then I can draw this line here, and then I want 90 degrees and the same length. So that would put it here. And then my last point is coming from here. So that will be here. Okay, so my rectangle will look like that. I were to erase the guidelines, it might look clearer. Okay, the other way you could do it is to take a piece of tracing paper. You'd still need to draw one of your lines to the point that you're rotating around, and then draw the same length at the appropriate angle to get one of your vertices. But then you can use your tracing paper and you can just trace out your shape and then line up the appropriate vertex and then trace your shape, and that would also give you your rotation. But again, you can do that with rotation about any point. You just draw a line to that point, and the important thing to remember is that the line on the, what we call, if we call this the actual object, then this will be the image that's undergone the rotation. And so the line from the object to the image must be the same. So you take the line from the object to the point of rotation, and it's got to be the same length from the point of rotation to the image at the appropriate rotation. Okay, before I go, I promised to let you in on a little mental trick I was using. First thing I want to say is this is another one of those you didn't hear it from me moments. If anyone asks, I will deny it, even though there's evidence. When rotating about the origin, and this is only true when you're rotating around the origin, you could say that the x-coordinate of the image is equal to the x-coordinate of the object times the cosine of the angle that you're rotating through minus the y-coordinate of the object times the sine of the angle that you're rotating through. And the y-coordinate of the image is equal to the x-coordinate of the object times the sine of the angle of rotation. Remember, positive angle of rotation is counterclockwise, plus the y-coordinate of the object times the cosine. Now that's quite a lot to take in, but for me it was easy because the cosine of 90 degrees is 0, so this disappears, and the sine of 90 degrees is 1, so this becomes 1, and the sine again is 1, and the cosine is 0, so we lose the whole of that. So the x-coordinate of the image is actually equal to the negative value of the y-coordinate of the object, and the y-coordinate of the image is equal to the x-coordinate of the object. And this was the little mental trick that was going through my mind when I was trying to draw the lines. You would use a ruler to measure the length of the line, and you'd say the length of the line goes from there, and you'd use a protractor to measure the angle. Or you'd use tracing paper to actually make the rotation. This only works about the origin, so it would be extremely complicated if you had to rotate, say, around point 2, -3, for example. If you had to rotate around that, it would be so much easier to just draw your lines and measure your angles than to have to redefine your axes and then recalculate the points of the vertices on your new system of axes and then use this formula to get your rotation. that's just really complicated, and it's certainly way beyond what you would be expected to do at GCSE level. So ruler and protractor is how you would rotate, and you would measure from your point that you're rotating the angle with a protractor, and you would measure the length with a ruler. And the most important thing to remember is the distance between the point of rotation and your object is the same as the distance between the point of rotation and your image, and it's the angle is going to be the same as you're given in the question. Okay, I hope you found that helpful. I'd like to wish you every success with your GCSEs and your revision, especially if you're taking them this year. Don't forget to like, comment and subscribe, and I look forward to seeing you in another video.